So cryptographic hash functions are a fundamental part of blockchain. If you understand hash functions, it will make understanding blockchain way easier. So a hash is a checksum derived from the block's information. You can compare a hash with a unique digital fingerprint. But why do we need hashes for our blockchain? So each block contains the checksum of the previous block. So if you want to hash a new block, you always have to include the hash of the previous block. This creates a direct link between the blocks, making our blockchain tamper-proof. So if someone would change an already documented transaction, let's imagine they would delete some of the transactions that are stored in a block, all successive checksum would suddenly be incorrect, and the whole system would notice that someone wants to cheat. So to trick the system, a hacker has to reverse the hash function by randomly trying. He needs to do this for every single block. So theoretically he can hack the system, but it's practically impossible, since nobody has so much computer power available. As a result, hash functions create security and we can therefore trust the system. Cryptographic hash functions have three important security properties. So first, they are pre-image resistant. This means that they are one-way. If you take a specific input and hash it, you create a unique output. So it is computationally impossible to compute the correct input value given some output value. So that means that you cannot calculate the input with a certain output. Second, they are second pre-image resistant. This means one cannot find an input that hashes to a specific output. More specifically, cryptographic hash functions are designed so that given a specific input, it is computationally impossible to find a second input, which produces the same output. And last, they are collision resistant. This means, if you take a specific input and hash it, you create a unique output. There is no way that somebody can find two inputs that hash to the same output. There are of course other security properties, but these are the most important ones. So there are lots of different types of cryptographic hash function. The most important one for blockchain is SHA-256, because many computers support this algorithm in hardware, making it fast to compute. So the number 256 generally refers to the length of the output. So SHA-256 will produce a 256-bit long output. That is the most common cryptographic hash function and the only one that you really need to know. Within a blockchain network, cryptographic hash functions are used for many tasks, such as address derivation or creating unique identifiers. They also secure block data. A publishing node will hash the block data, creating a digest that will be stored within the block header. And last, they secure block header. So a publishing node will hash the block header. If the blockchain network utilizes a proof-of-work consensus model, the publishing node will need to hash the block header with different nonce values until the puzzle requirements have been fulfilled. The current block header's hash digest will be included within the next block's header, where it will secure the current block.